Hello and welcome to Barkman Labs. Today we are doing the soda can crush, which is an experiment that involves using a soda can and all this various labware to explore two different gas laws. Charles's law, which deals with temperature and volume, and Boyle's law, which deals with pressure and volume. We're going to try to explore and learn a little bit about both of those laws with this lab. So first things first, you need to fill up your ice bath maybe about halfway or so with ice, and then near the top, I'd say 4/5 of the way from the top, I've got my with water. I've got it right about here right now. The reason that this is actually a control variable, which I know sounds kind of odd to think about how much ice you have in there as a control variable. The reason it is you're going to be heating water in your can, and you're going to be dunking it into the ice bath. If you've just got that packed with ice, it's not going to go it's not going to be submerged very well. And if you've got not enough ice, your temperature of your water might get a little bit too warm, and then you're not getting a nice consistent cold temperature that you're dunking the hot can in. So get that ice level with enough ice that the can can easily be dunked in there, but not too little that it's all melting. And you're going to kind of want to monitor that throughout the experiment. Next up is you want to add 20 milliliters of water to your can. You also want to make sure this can is rinsed and empty. If you've got any sugar leftovers in there, it could kind of caramelize and make the whole room smell. That's happened before. That's not a big control variable, but if let's say that there's some liquid left over in here, when you add your 20 milliliters, now you've got 25 milliliters or something else. So that can actually matter. So I'm going to go ahead and add some water to my graduate cylinder. Got me pretty close, and then it's not a bad idea to use a pipette to finish it off and get it really nice and close to exactly 20 milliliters. So I've got this at 20 mils now. We're going to pour this in here, and we're going to put the can on the wire mesh. Now, thinking about variables again, how close you have the can to the Bunsen burner wouldn't be a control variable. It is going to change how fast the water gets to different temperatures, but it's not actually going to affect your dependent variable, which is how much the can crushes. So yes, that's a difference in the lab, but it's not a control variable difference. Also, what temperature the water is that you start with, that could differ based on lab group or based on the day, but that's not a control variable either, because you care about what the temperature is at when you dunk it, not what it starts at. It doesn't matter if it starts at 20 or 25 or 23 degrees. So now that you've got this heating, you can use your thermometer to monitor the temperature, and you're going to want to shoot for temperatures above 50 degrees Celsius. I don't really care that you measured exactly at 70 or exactly 75. Measure what it actually is, and then dunk it at that temperature. So I'm going to go ahead and turn off my gas, and right now I'm at 80, 81.2, 82.8, 83.9, 85. Here's a big control variable, is letting that temperature somewhat stabilize. It's going to be harder at the higher temperatures. 88, 88.3, 88.5, 88.7, 88.8. Notice that the temperature keeps on going up. It's because it's kind of mixing and evening out. And it takes a while for the thermometer to reach that temperature. So now we're at 89.0. It's stabilized at that, so I'm going to go ahead and grab this with my tongs and put it in there, and here we go. We've now got a crushed can. That was at about 88.0 degrees, so that would be my independent variable, the temperature that I crush it at, and my dependent variable is going to be how much the can crushes. You might ask yourself how you can measure that. Good news is we know what it starts at. It starts at 355 milliliters exactly, and then you go over to your sink and fill this all the way up to the top. And doing this consistently would be a variable. Fill up the top of this can and pour it into your large graduated cylinder. Okay, I spilled a few drops there. You probably don't want to do that. And this tells me it is at 250 to 75. This is 5. This is at 295 milliliters. So that would be your dependent variable that it crushed from 355 down to 295 milliliters. We're going to be doing some graphing and some calculations with some of those numbers. But now what you would do is you would go ahead and you would try this again with another trial at a different temperature. We're going to do varying temperatures from, like I said, about 50 degrees Celsius all the way to boiling, which in Denver, remember, is about 96 or so degrees Celsius. Other control variables that you want to be careful with, obviously, dunking it right side up is going to be very different than dunking it upside down. We're going to talk about that and draw some pictures about why that is in class. How much you dunk it, so if you just kind of lightly put it in there versus submerge it completely, that is another control variable. So you want to get it kind of as completely submerged as possible. It's going to take some practice. You might mess it up a little bit here and there, but you want to be consistent, you and your classmate, with that. And one final control variable that you might not think about is how long it boils for. So when it's sitting on, or how long it heats for. When it's sitting on here, if you're kind of taking your time and it's boiling away for a while, you're not going to have 20 milliliters of water left in there. Maybe now you've got 15 or 10 or 5, or some people who've waited a really long time have no water left in there. Any of those changes is going to affect your experiment because you've changed that control variable of the quantity of water left in the can here. So that is the soda can crush lab. We're going to explore how those different temperatures of the water affect how far it crushes down when it gets cooled down, and we think that's because there are different pressures of steam inside of this container at the different temperatures. So there's a lot of analysis to do with that after we are done, but that is the general gist of this lab. Have a nice day, and I will see you in lab.